Okay, in this video, we will be discussing the last topic on this module, which is the higher order derivatives. So, from the given function, or for the original function y is equal to f of x, kinuha natin ang derivative, kaya magiging derivative of y with respect to x is equal to f prime of x. So again, we denote this as the first derivative y prime. So if we get the derivative, the first derivative, that is taking the derivative with respect to x of our first derivative of y with respect to x, we get the second derivative of y with respect to x. So this becomes second derivative of y with respect to x. So that is written as d squared y over dx squared, and read as second derivative of y with respect to x. So this time, instead of 1 prime, magiging na siyang double prime. So this y prime, magiging na siyang y double prime. And derivative with respect to x of the derivative of y with respect to x gives us second derivative of y with respect to x. So these are some notations na pwede nating makita. Further differentiation, magkakaroon tayo ng derivative of the second derivative gives us the third derivative, and the derivative of this third is the fourth derivative, and the derivative of this fourth gives us the fifth derivative, so on and so forth. So, please take note lang na ang y fourth na merong parenthesis signifies the fourth derivative. So this is not equal sa y to the fourth. So y to the fourth is y times y times y times y. And y open parenthesis, close parenthesis sa 4 means the fourth derivative of y with respect to a certain variable x. So para lang hindi tayo malito. So yung fourth na yon na ka-open and close parenthesis signifies, or notation natin is the fourth derivative. So let's try to illustrate this by giving examples. So if I have here, say y is equal to x to the 5 plus 3x minus 4x squared plus 3x to the third power minus 5, and we are looking for, say, the fifth derivative of y with respect to x. So that is, we had to take the first derivative, then the second, then the third, then the fourth, and then finally, we take the fifth derivative. So, kunin muna natin ang first derivative, y prime. So, y prime is the derivative of the first. So, gagamit tayo ng derivative of sum. So, derivative of the first, derivative of the second, derivative of the third, the fourth, and the fifth term. So, this is 5x to the fourth. So, yung exponent natin pupunta sa harap, then subtract 1 from 5. That's plus 3 minus 8x. Multiply natin yung 2 sa 4, then subtract 1 from 2. Then this becomes plus 9x squared. Multiply 3 by 3, then subtract 1 from 3. Derivative of 5 is 0. That's our first derivative. Taking the derivative of the first derivative gives us the second derivative, y double prime. So taking the derivative of this one, that's 20x cubed, because 4 times 5 is 20, subtract 1 from that, derivative of a constant 3 is 0, derivative of negative 8x is negative 8, plus 18x. Subtract 1 from 2, that becomes 1 na lang, and multiply 2 by 9. So that's why it's 18x. Then taking the derivative ulit, that's the third derivative. So this gives us 60x squared, because 3 times 20, derivative of negative 8 is 0, derivative of 18x is 18. Then taking the fourth derivative, we have 120x, because 2 times 60 is 120, subtract 1 from 2, that is x to the 1. Then derivative of 18 is 0. Then y, fifth derivative of y with respect to x is simply 120. So thus, the fifth derivative of y with respect to x is simply 120. So pag gusto mo pang hanapin ang 6th derivative, that is 0 na. So since ang required lang ay 5th derivative, i-leave natin siya as is. So another, so what if I have y is equal to 7x minus 2 over 3x minus 5, and we are required to find the second derivative. So meaning, kukunin lang natin ang derivative ng function and take another derivative. So kukunin natin ang pangalawang derivative. So this is a quotient, so that's why we will use quotient rule. So for y is equal to 7x minus 2, and then u is equal to 7x minus 2, and du is 7, v is equal to 3x minus 5, then dv is 3. So again, ang formula natin ay v du minus u dv over v squared. So again, u is 7x minus 2, whose derivative is 7, and v is the denominator 3x minus 5, whose derivative dv is 3. So substituting to our formula, y prime is equal to v, that's 3x minus 5, times your du, which is 7, minus u, which is 7x minus 2, multiplied by our dv, which is 3, all over v squared, which is 3x minus 5, raised to the second power. So simplifying your numerator by combining like terms and distributing 7, that becomes 21x minus 35, and then negative 3, because this is preceded by a negative, times 7 is negative 21x. This becomes plus 6 because negative times negative is positive. Then obviously 21 cancels out. This becomes negative 29 over 3x minus 5 squared. So that is our first derivative. But since ang required natin ay second derivative, ikukunin ulit natin ang derivative nito. But this can be written as negative 29 multiplied by 3x minus 5 raised to negative 2. Pwede natin i-convert ang quotient rule into a product rule by using Lawson exponents. Or pwede naman tayong gumamit ng formula na k over v. So that's another choice. K over v, since k is 29, negative 29, and v is 3x minus 5 raised to the second power. Or we can use just chain rule dito para ma-solve natin ito. Then taking the second derivative, that's negative 29, you multiplied by negative 2, that's positive 58 na. 29 times 2, that's 58. Multiplied by 3x minus 5 raised to negative 3 because we need to subtract 1 from negative 2, and then you multiply it by the derivative of the function being raised to that constant exponent. So therefore, our second derivative of y with respect to x that we're looking for is 58 times 3, that's 24, carry 2, 174, times 3x minus 5 to the negative 3, or 174 all over 3x minus 5 to the third power. So again, basically, what we are doing is to take the derivative of the first para makuha ang second derivative, derivative of the second para makuha ang third derivative. So that is the principle para sa higher order derivatives.